And the respiration, based on this final inorganic chemical, we separate them into two categories. If this inorganic chemical is oxygen, we call it aerobic respiration. This is easy to understand. And if the final electron acceptor inorganic chemical is not oxygen, is others, for example, sulfide, that is called anaerobic respiration. Now, obviously, you will see the final energy generated through aerobic respiration is much more than anaerobic respiration. And we will talk about that in detail. Okay? So, let's talk about fermentation first. What is fermentation? This slide here, which is well explained what I draw here. So this slide actually is explained here. Okay, so we want to talk about fermentation. What is fermentation? Fermentation, said very simple. There are two categories. This is just an overview. If we want to talk about the fermentation, that could be talk about the whole class, whole semester could talk about. What are the two? Number one is pyruvate become lactic acids. Coupled with NADH2 become NAD plus. Okay, what is pyruvate? COOH, CH3. Okay? Let me draw another one. You understand? Let me draw another one. CH3, the ketone right in the middle, COOH. Look at here. There's two protons there. Is that right? 2H. They lost, become NAD. So what they go? They transfer to here. And this is a ketone. It's not stable. You're going to ready to add. So what is lactic? What is the lactic acid structure? So very simple. If you know this one, COOH is the same. What's the difference? H and H. So always remember, organic chemistry, you don't have to recite. And you just go ahead and recite, oh, it's tough, tomorrow we're going to have an exam. If you know the story behind it, this is very easy to add it. That's lactic acid. It's an antimicrobial chemical, okay? So pyruvate become lactic acid. This is a reduced product. Is that right? So we also say pyruvate reduced to lactic acid. How about NADH2 become NAD? This is an oxidized product. But I tell you one thing here. This guy is important. Because they have those empty space, you could ready for another two proton to go in. This will explain the definition here. If electron donor is an organic chemical, pyruvate is an organic chemical. Electron acceptor is also organic chemical. Lactic acid is an organic chemical. This is called fermentation. And we also call this is a hormone fermentation. Okay, we call it a hormone fermentation. Now, lots of you like beer, wine, all those things. So what happened? Again, pyruvate. Pyruvate will going through a process NADH to reduce to NAD, and they're going to be released carbon dioxide, then become acetaldehyde. And this acetaldehyde will further reduce NADH, become NAD plus, will become alcohol. Or we don't say it, we say it's ethanol. Okay, ethanol is actually alcohol, but we just say ethanol. What the structure looks like? Pyruvate, okay, lose carbon dioxide. This is gone. So become here what? CH3CHO. This is called aldehyde. And then you go here, become ethanol. These two, put them back. So what it looks like? CH3CO. O, this is H. And you go down is H. And here is H. Therefore, the ethanol you also could write C2H5OH. Is that right? That's what the ethanol. Now, this is also a pyruvate, is an organic chemical. The ethanol is an organic chemical. So, electron donor is an organic chemical. Electron acceptor also is an organic chemical. And if the fermentation process generates not only lactic acid and other chemicals, let's say ethanol, we call it heterofermentation. And if they only generate lactic acid, we call it hormone fermentation. Okay? Now, of course, the second step is complicated. This is just the outline. So, give you an example. You like beer. There's basically two types of the beer: ale and lager. Is that right? One is light color, one is dark color. Why? Because one do top fermentation, another one do deep fermentation, and the temperature is different. Sometimes the pressure is different. So, although they all generate ethanol, but the process in the middle is different. And this is only an outline, which tells you very simple from pyruvate fiber generate is ethanol. But if you really talk about the food processing, there is a lot we can talk, and a lot are different. Okay, so this is the second thing talk about fermentation. Third thing talk about fermentation. We know that fermentation we're going to do in the absence of oxygen. This is simple. Everybody knows. The last thing. How many ATP going to generate? Only 2 ATPs generate. And these 2 ATPs through substrate level phosphorylation. Where those two comes from? Coupled with glycolysis. So, in a moment, we're going to mention glycolysis real quick. Okay? That's what's the knowledge you could be put together. Okay, before we talk about glycolysis, let's have fun a little bit. This is what you like. Products from fermentation. Okay, glucose become pyruvic acid. This first talk, we're going to talk glycolysis. You don't like it, it's okay. This is, you may be interested. Do you like Swiss cheese? Very acid. So we have a hole there. What are they? Carbon dioxide. Why it's so acid? Probionic acids. So what's the bacteria cause this? Simple, probionic bacteria. Okay, do you like cheddar cheese, yogurt, soy sauce? Yeah. I have a yogurt in my home. I have a yogurt in the office even. I don't eat it real quick in like 1 hour. What's the final product? Lactic acid. This is important. And what are the bacteria? Lactobacillus, of course. Aspergillus, and very surprisingly, Streptococcus. This is a Streptococcus thermophilus. Okay, this Streptococcus is not the pathogen. This is Streptococcus thermophilus. Very interesting. This pathogen is only for fermentation. So you don't see Streptococcus think it's all pathogen. No, this is beneficial bacteria. Next one, you like it, wine and the beer. What is the yeast we do? Saccharomyces cerevisiae. Remember the first class in the lab, we do the observation, generate the carbon dioxide is a bubble, and ethanol. Is that right? That's heterofermentation right here. Okay, next one, the girls like it. Acetone and isopropanol. You go Sephora, you go Ulta, you can get a bottle of a nail polish remover. It's expensive sometimes. Where they come from? Clostridium. Remember, Clostridium is an anaerobic bacteria. They don't like oxygen. So in anaerobic environments, they will go through fermentation and generate acetone. What is acetone? Three-carbon ketone is acetone. Okay, we'll talk about real quick. That's the nail polish remover. Last one, vinegar. You like vinegar? Sometimes, well, it's good for health. Using for tenderize of the meat in the meat industry. Which bacteria use it? Acidobacter. So we generate acetic acid, so we call it acidobacter. It's easy. Another thing is very interesting. Look at the E. coli. This is not E. coli 0157H7, not a generic E. coli, not the E. coli we did in the lab. This is E. coli 9037. It's a beneficial bacteria for vinegar to use. So when you see E. coli, it does not mean it's all passive. It's a beneficial bacteria, generate vinegar. It's an acidic acid will generate. Okay, so this is just one relation though. Our fermentation process is complicated. Different pathogens responsible for that will generate lots of the products. It make our life really nice, and lots of them are more complicated story behind that. But the bottom line is all those two. Okay, and in the absence of oxygen, going through substrate level phosphorylation, only 2 ATP generate, and it's coupled with glycolysis. Where you can see is right here. You can see it. Okay, so next we want to talk about glycolysis. So this is we want to spend time talk. So some of you already learned in your biochemistry class. Who had the exam just last week? Yep, that's good. Help you. We will be emphasizing here. It's like a review section. Okay. Some of you never take a biochemistry class, so we will be the first time you learn. So we're going to talk a little bit of detail, but keep in mind we will be focused on bacteria. Basically, use E. coli as an example. So most of the time is same as your biochemistry class. Little bit different. So let's talk about glycolysis. Glycolysis. Detail will be here. Overline will be here. Okay. So what is glycolysis? I always like to talk about this word. You can cut into two. What does lysis mean? To take it out, take it out. What is glyco? Carbohydrates. And what is the most widely used carbohydrates for bacterial cell? Is glucose. So that's easily understand. So what it looks like is glucose will generate interdisciplinary material is called fructose 1,6,5-phosphate. And I use P to indicate the phosphate or phosphorylation, okay? Then this is going to become a branch, goes here. And finally, what will generate? Will generate pyruvate. And I want to tell you one thing, this pyruvate later on, in the presence of oxygen, will go citric acid cycle, or tricarbonic acid cycle, TCA cycle. We just mentioned in the absence of oxygen, going through fermentation. Okay, this is a key thing here. It's a pyruvate. So we want to mention is this section is called glycolysis. There are two stages of the glycolysis. On the top, 6-carbon area. Bottom, 3-carbon section. And we also call 6-carbon area is investment. What it means by investment? You don't buy stock market. You don't buy stock. So if you buy stock, you put $1,000 there, you want to get $10,000. That's called investment. So the first you put $1,000, that is investment. Here, we talk about ATP. It's used to ATPs. And I'll show you the detail. It's just a conclusion, okay? Now you see the 3-carbon section. The 3-carbon section right here, we call it a payoff. Which means it's going to generate more money. Here, the money is ATP. So how many ATP generate? 4 ATPs. So at the end of the day, how many ATP generated during glycolysis? -2 plus 4 equals 2 ATPs. That's why what I'm trying to say, coupled with fermentation. So here is something I want to mention. Glycolysis process generated 2 ATPs is coupled with fermentation. If glycolysis not go fermentation, they go citric acid, then more ATP will generate. So you should know in your biochemistry class, the conclusion is glycolysis have 2 ATP generate is individual closed branch reaction. It's not related to aerobic respiration. If it's related to total aerobic respiration, the story is different. Okay, so we want to talk about that. Then we're going to draw the picture right here. What it is, name and structure. I came here really rush, so I may not know all the chemicals, but I'll try. If I forgot, I'll look at my notes. But I think I have a good memory, so we're going to do it. Okay, let's talk about this top first. First thing, if you need extra points, make sure you know those structures. And you know all those structures, the first thing you need to know is glucose. So what is glucose? 6-carbon sugar. HOH, HOH, OH, H, go down, OH, H, go to the top, H, CH2OH. That's glucose. Very simple. If you don't know glucose, then it's hard to explain. So in the exam, how many extra points I get? 1.5. Glucose 0.5, structure 1.5. Okay? So glucose then become first step glucose 6-phosphate. Okay, let's say you drop. You already know glucose. Okay, so we go OH, OH, H, OH, H, and go here H, CH2O. The phosphate goes here. This is called glucose 6-phosphate. Okay, lots of the topic we could talk. Number one, review your biochemistry reaction, your organic chemistry. Why this is called glucose 6-phosphate? Why? How we label it? Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. That's why it's called the glucose 6-phosphate. Second question, what is the enzyme for that? And you learned in your class, and you said, Dr. Xu, you don't need to tell me. I know. This is called hexokinase. Why it is hexokinase? Because hexo means 6. That's easy. But I tell you, in my class it's wrong, maybe. Why? We talk about the bacteria. What you learned is human being and animal, same as fungi. So how we come here? Do you still remember how glucose become glucose 6-phosphate in a bacterial situation? They going through group translocation. You did very good in exam 1. Go look at your slides. So a little bit difference right here. Okay? In your biochemistry class, because it's it's hexokinase. For bacteria, it is from group translocation. Which chemical do you rely on? Phosphoenolpyruvate. We'll talk real quick. Okay, now the key. Where this phosphate comes from? We already talked about this is investment. So ATP hydrolyzed become ADP, and the phosphate, this phosphate comes. So become glucose 6-phosphate. Okay, let's go down a little later. This is kind of tricky but easy. Okay, we're going to change the morphology. Looks like it's different. CH2, OH, 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 H, H, OH, OH, CH2, O, this P is right here. What is this one called? 6 carbon sugar become 5 carbon sugar. This is called fructose 6-phosphate. What's the enzyme for that? So we need to talk about what's the similarity between glucose and the fructose. Their chemical components are all the same, but their structure are different. Is that right? One is 6 carbon sugar, another one is 6 carbon rings, another one is 5 carbon rings. So what's the enzyme for this one? Isomerase, because it's an isomerization. Glucose 6-phosphate is isomerization of glucose 6-phosphate. Okay, is this balanced? No, it's not balanced. We all like balance, not symmetric. That's why we need to add something. So the next one. I want to tell you that these things are not difficult, because the reason it's difficult is because people don't explain very well. Okay? CH2O go here, add a phosphate, add a go OH, then go OH. These are the same, you can just copy. It's all the same. Okay, OH, CH2O. Then what's this? This is already fructose. Already 6-phosphate. This is carbon number 1. This is carbon number 6. So what is this? Fructose 1,6-biphosphate. It's a balance. Then what's the name of the enzyme? Fructophosphokinase. That's easy. about the investments, this is one ATP, another ATP. ATP hydrolyzed become ADP and the phosphate. Okay, investments. So this guy comes in. That 6 carbon is gone. So we're going to move on to 3 carbon right here. Okay? So 3 carbon right here. Now you have this chemical right there. Okay, you have this chemical. We draw it again. Here on the top. A little bit small. CH2O. Just draw briefly. Okay. Is this guy looks like very symmetric? Is this guy looks like a beautiful structure? Yes. Once you see these things, it's not really nice. People see it's very symmetric. It's like a cake. What do you want to do? You want to cut it because I want to eat it. So they cut in the middle. That's what happens in the biochemical reaction. It's like a cake. They bring the cake to the dome. Everybody want to cut a piece. So cut down in the middle. Cut down in the middle becomes 3 carbon. What is that? CHO, CHOH, COOP. Sorry, CH2OP, not COP. CH2OP. What is this? Glyceroldehyde 3-phosphate. Because we cut it, what is the enzyme? 6 carbon sugar becomes 3 carbon sugar. Aldolase. Now this is something you may have to remember. Aldose, which means 3 carbon. Okay. And in your textbook, it's going to talk about there is a transition step right here. It could be somehow go this way, somehow go back. The structure called CH2OH, then goes CH2OP. This is we call it dihydroxyacetone phosphate. So what is acetone? 3 carbon ketone. That's a ketone. Okay? And you need to know this is ketone. And what is this?